Hello and welcome. In this tutorial, we are going to look at how to do data analysis using R. We will look at how to load data and inspect data in R, how to do data preprocessing, how to do various plots, and then how to run descriptive statistics and regression analysis in R. Now, if you have not subscribed to this channel yet, kindly subscribe. And without wasting much time, let's launch the R GUI and see what is there. So this is the interface when you launch the R application. This is the R GUI, R graphical user interface. So here is where you type the code, and when you start it first, you usually have this message printed out here telling you the version of R you are using. Now I am using version 4.3.2. If you are using later version or earlier version, you still should be able to do whatever we are coming to do here. And it also tells you how to quit R using the Q bracket open bracket close function. To analyze data in R, first you'd always have to import the data into R. And let me open Notepad++ here. That is where I am going to be doing the typing. I usually type my code in Notepad++ and then copy it and paste in R. I don't want to be having a lot of errors in R. Sometimes when you type directly into R, you've made a little mistake and then you hit enter and then you get an error. So I always type my data in Notepad++, make sure it is okay, then I copy it and paste it in the R console. So this is Notepad++ that is opened here, and it's just a text editor. But this one you can write various languages. You can use it for various languages: Python, C++, C, whatever you want. You can write it here and save it accordingly. But here we are going to be typing R codes. So you type it here, just like this, then copy and go and paste in the R GUI. Alright, so like I said, to analyze data in R, first you usually have to import the data into R before you can do anything with the data. So let's say you have a data set in your PC and you want to analyze it. You would have to import it, and to import it, there are various ways of importing data in R. And there are a couple of functions you can use to import data into R. One of them is the read CSV function. It is like this: read.csv bracket close. Right, so you provide your file path here, and then this function accepts a lot of arguments. We will come to that. But there is another one called the read table function. It is also read.table bracket close. Now these two functions, they work the same and they actually accept the same arguments. So you can either use read table or read CSV. Well, I always use the read CSV. So if you have your data you want to import into R, you can use the read CSV. So for the arguments that are passed into this, the first thing you usually pass into it is your file path. That's always come, and the others. So let's look at some of the arguments that the read CSV function accepts. Now to see what any function does in R, to see what any R function does, you can always use the question mark followed by the function and then you hit enter. You get the manual page of the function and then it will describe what the function is used for. It will also give you the arguments that are passed into the function, and also example usages. So let us try that with the read CSV function to see some of the arguments. So we will go to the argui and type question mark read.csv into it and see and press enter. So it is starting to open the manual page of the read CSV function. So this will open the manual page of the function in your browser. Let's look at what is there. So alright, so we have the manual page open in Chrome here. By the way, my default browser is Chrome, so that is why it is open in Chrome. Right, so you see I told you earlier that the read CSV function and the read table function, they are kind of similar. So you see that when we type for the manual page of the read CSV, but we actually got the read table function. They are almost the same. So, and I said it will give you a brief description. It says reads a file in table format and creates a data frame from it when cases corresponding to lines and variables to fields in the file. With cases corresponding to lines and variables to the fields in the file. Right. So this is an example usage here. So to use it, you usually type the read CSV and, like I said, your file path. Now, these are some of the arguments these functions accept. What is the header argument? So now, if your data set has header, you would set this argument to true. If you set it to false, it will consider your data set as no header, so it will consider everything as entry. But when you set the header argument to true, it means the first row of your data will be the column headers, and then the separator, that's the delimiter, the kind of file you are importing. If it is a comma separated file like CSV, and then you set the separator argument inside these quotation marks to the particular delimiter. So if it is CSV, you just put a comma here, comma separated. If it is tab separated, you just put or space separated, you just put the space inside these two quotes. Right. So another one is the quote function, the quote argument. Sorry. This one, sometimes in data entry, people enter string values using quotation marks around them. So if your data is like such, where string character values are in quotes, so you assign this quote argument, and then you put the particular quote, whether it is double quote or single quote. So if your data is not quoted, then you will just leave this thing. In most cases, data is not quoted, so you just leave it out. And let me see, there are a lot, but we will just go through a few of them. And another one is the call names. This is column names. You can provide column names. So let's say your data doesn't have header, so you can provide header names here. So to provide header names here, you just give a vector of headers. Let's say I have my data. Let's open Notepad++ for this one. So say I have my data and the data has no header. So I'll set the call dot names argument, and then I'll provide a vector of names. So let's say to do this, you use the cbind function, c into bracket, then you put them here. So let's say I have column 1 input column 1, comma, I have column 2, I have column 2, comma, I have column 3, comma. So I'll just do it like this. Let's say I have my data has 2 rows, I mean three columns. So this is what I will do. So it will use column 1, column 2, column 3 for the data, the headers, the column headers. So now if your data has headers and you don't want to change them, you don't bring this thing. Alright, so that's it for the header, the column header function. So there's another one too. Sorry, let's go to the browser. The row names. So it's also the same. It's also like the same. So you provide row names. If you don't provide it, to use the first column as the row names. I mean, no, it will use the row indexes. So it will name them from 1, 2, 3, 4, 5, 6 up to the last row. So if you to provide the row names, you can do it like this. Let's go to Notepad++ again. So for row names, you can either provide row dot names. You can provide names like this. You can provide names like this, or you can use one of the columns for your row names. Let's say I want to use column 1 for my row names. I'll just say, okay, row names is equals to 1. So column 1, the first column will be used as the row names. If I want to use column 2, just say 2. So column 2 will be used as the row names of my data. Alright. If I wanted to just do it like this one too, I will just provide them myself. So I will say row 1 like this. So you have to, if you are using strings, you have to character values, you have to put them in quotes. So I'll have row 2, I'll have row 3, I'll have row 4, so up to the last row. I will name them. If I have 100 rows, then it means I have to provide 100 values for the rows. Alright, so let's go back there and see what we have again. Alright, so these are what we would look at for now. So you can always use the question mark followed by the function to get this manual page, and then you can look at what you can do with the function. As you can see, so we have the read CSV also here. Like I said, they are the same, so they accept almost the same things. Yeah. So let's talk about this one, the strings as factors argument. Now this is very, very important. In R, when you import your data without specifying this strings as factors argument, it will treat all string values or all character values as factors, as categories. You know, when you have data and it is categorized like weeks, you have like days in the week, you have Monday to you have Sunday to Saturday, right? So these are categorized. You can either be in one of the 7 days, but in most cases, not all your columns are like that. Let's say in one column there are names of people. So if you categorize it like that, that is wrong, because names of people is not categorical, because it can be anything. It doesn't fall within specified category, so it can be anything. So to deal with that, it is usually safe to assign these strings as factors argument to false, so that in processing your data, you can now convert all columns that are actual factors to factors using the as.factor function. Okay, so you can in importing your data, you can do this one to false. In that case, string will leave your data as it is, so that when you are now working with your data, if column 1 is factors, then you can say as dot factor, then column 1. Then need to treat column 1 as factor. So this is how you do it. Let's go to Notepad++. So say I've imported my data and I want to work with column 1, and I want to make it categorical. So I will say I will use the as dot factor function. Then I will put, let's say, my data and then the particular column. This is how you access the particular column. So let's say column 1. So in this case, I will treat column 1 of my data as factors. But here I am specifying, right? Here I am specifying that treat my column 1 as factors. These are categorical, so treat them as factors. So in this case, you have control. You are controlling what R is doing, not R doing something for you. All right. So now again, so let's try and then import some data into R and see how it works. So we use our read CSV function. So like I said, you have to provide your file path. I have a CSV file here. Let me find the file path and then you will use it for example. I think I should have it here. I think it is called data dash or something. Yeah. It was some work we did some time ago, so alright, it is here. So I will just copy the file path and then come and paste it here. So your file path has to always be in quotes, otherwise it will not work. So you put it quote file path on quotes, right? It has to always be in quotes, otherwise you get error. And you see that when you copy your file path, you have the directories separated by backslash. But in R importing data, you usually you use the forward slash. So you change all these backslashes to forward slashes. Otherwise, you get error again. So you change all of these to forward slashes. Forward slashes. So I think in Mac, if you copy the file path in Mac, you actually have the forward slashes or something. I don't know. I use Windows. So in Windows, anytime you copy file path, you always have the directories separated by backslashes. So you have to change them to forward slashes. So remember this: quotes surrounding your file path, and then backslashes to forward slashes. So the reason being that in most of the programming stuff, backslash is always used to put a special character in R. So let's say somewhere in my file path there was a special character there. So I will use the back let's say there's something like space. Somehow, let's say I have space in the name of my analysis, something like this. So if I leave this one like this, it will not work. I have to use the escape function, which is the backslash this. So in this case, I am saying I am escaping this function. Treat it as part of the file path. Otherwise, it will be read up to this point and then stop. And it will not find your data. But if I escape it, then I'm kind of like telling you, okay, this is part of the name of my file. Okay, this is part of the name of my file. Right, that is the reason you have to use the forward slashes. Backslashes is used to escape special characters. All right. So we have our file path here. So this data has headers. So you will say header. The header argument you set it to true. So use upper cases for logical boolean values in R. If you are writing true, you use upper cases. If you are writing false, you use upper cases. All right. So we also use the strings as oh, so you use the strings as factors argument, and then we will set it to false because we don't want R to change our strings to factors, right? So we can also provide our delimiter. So sep so this is a CSV file, so we put into bracket unquote comma. All right, so we are telling R that our data is separated by comma. It's a CSV file, CSV, so comma separated variables. So our data is separated by comma. If our data was separated by spaces, then we will say space in quotes. Or if our data was separated by slashes, then we will just put slash. So we are telling R anytime you see a slash, it is separating our columns. We are moving from one column to another, right? Okay. So we are good to go. Right. So you see, I've been talking about this, but I have not spoke about Excel data. Excel data. So if you have your data in Excel format, any of these functions will not work. Cannot import Excel data. Okay, any of these functions cannot import Excel data. So you have to use a different package. That one you have to actually install a package that will allow you to import Excel data in R. In the base R, you cannot read Excel data in the base R. Okay, so but there is a way you can get out of this without having to install the package. You can always convert your Excel data into CSV format. So when you open your data in Excel, you go to save as. So you provide the name and then you provide the file format. In the file format area, you change it from Excel worksheet, you change it to CSV, comma delimiter. Okay, so let us import this data into R and see what we have. First, let's double check to make sure our code is correct before we run it so that we don't get errors. So we have our separator, we have our strings. No, this should be strings plural. Strings as factors. Yes, strings as factors is equals to false. So we have our header and we have our file path. All right, so let's store this in a variable called data. So that to do this, you write data and you give it this assignment greater than dash now with your file path. So in R, where you do this, you are telling R that take whatever is in the right side and save it as what is in the left side, so that when I'm mentioning what is in the left side, I am referring to what is in the right side. Okay, so in this case, if we run this in R, anytime we say data in R thinks of this whole thing. Now if we run this one directly in R, it will try to print the data, to try to print all the data into the screen. So let's try it. Let's just do it before we assign it into the string. So you copy this one and go to our RGUI. As we have our RGUI here, and then we paste it here and run. Alright, so you see, like I said, you see what has happened. It has printed the whole of our data. Now this data is about 1,000. This is about 1,500 entries. It's about 1,606 entries. R has printed everything on the screen because of how we did it. And this is not good. You see, you can't even scroll to the end. This is not good, especially if you have a really large set of data. Let's say this was about tens of thousands. So R will be trying to print everything onto the screen, and this might take a very long time, or it might even overwhelm our memory, and then the whole thing will crash. So to do it the right way, you create a variable and you give it the assignment operator. Say, okay, store my data into this variable so that when I mention this variable, I'm talking about my data. Okay. Alright. So when you have a full screen like this, you can always clear it using Control plus L. Control L will clear the screen. So you have an empty screen again you can work on. So let's go back to our Notepad++, and then this time we will store our data in a variable called data, so that when we mention data, we are talking about our data set, right? So let's go back to Notepad R GUI and paste this thing there and run it. Alright, so now you see the code has been executed, but nothing is printed. Okay, nothing is printed. So we can take a look at our data, but we don't want to print the whole data. So in R, you can take a look at part of your data without having to print the whole thing if you have a large data set. So to do this, we have the head function. We have the head function you can use to print a specified amount of rows you want in your data set. So let's go back to Notepad++ again, and then we say you use the head function. So our data, bracket, our data, bracket close. So by default, this will print the first 6 rows of our data, but we can specify the number of rows we want by giving a number here. So we bring our data comma and specify a number. Let's say we wanted the first 10 rows, so we will just put 10 here. So let's run this one in R and see what we have. We copy it, go back to RGUI and paste it there and run. Alright, so you see that it's only part of our data that has been printed. Okay, we have the first 10 rows. You see that they are numbered from 1 to 10. We have the first 10 rows of our first column, second column, third column. We can actually count the number of columns. There are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns. Okay, there are about 10 columns. So you don't have to sit and count this one by yourself. There's a way of looking at it. And to see the structure of your data, you can use the str function. It will print the structure of your data in R. So to do this, you use the str function, and this is how it is done. You just type str bracket then your data, right? So you will copy this and paste it in R. Let's go back to R, right, and paste this in there and run it. So here you see it has listed our columns. It has listed all our columns here, and it tells us how many rows we have by how many columns we have. So we have 1,606 observations, that's rows of 10 variables, that's 10 columns. And it will tell us the data type of all our columns. So the first column, I think it is this one is what do you call it? It's a number we give to participants in the studies. Okay, so it is the identification number of the participants in the study, and it is numeric, so it is an integer. It is not decimal, so it's an integer. If it were decimal, then R will say double. It is an integer, so you see 8. The rest are think, okay, there's another 8 here. So 2 integer variables, and the rest are character variables, so strings. It will tell us, then to print the first few entries. Okay, so there's another way to look at this, the structure. Instead of printing all these, you can just print only the number of rows by the number of columns. Okay, to do this, you will usually use there's another function called the dimension function. It is called dim, the dimension function. So how to do that one is, we say print the dimension of our data. So we use the dim function, and then we provide our data. So if we run this, we should get the number of rows by the number of columns. Okay, so we go back to R, and then we run this. Let us clear the screen and then run this. Alright, you see it. It has printed 1,606 by 10. So 1,606 rows by 10 columns. Now, our output usually gives you this. But if you don't want this, you just want to print only this, you can use the cut function. If you use cut, by the way, you can always repeat your previous code by pressing the top arrow key. If you press the top arrow key, you get your previous function. You press it again, you get the next previous one. Then you get the next previous one. Okay. If you want to go back to the function you just passed, you press the down arrow key, and then you get this one. So we can just print it without this index here, using the cut function, passing it into the cut function, bracket close, and then we will have it without this. Okay, now this is human readable than this, right? Now you don't have your your index here. Okay, all right. So another thing we can also do is we can try to look at a brief summary of our data. We have what is it? When we look at the structure of our data, we have integer values. Okay, we have integer values. So we can look at basic descriptive statistics of our variables. Now this is just to have an idea, but we have not processed our data yet, so this doesn't offer much. But we can look at it. Okay, so we can use the what do you call it? The summary function like this. Notepad plus plus. Okay, I've opened it already. So we can say summary our data. So this should give us, let me give a space. This should give us the basic descriptive statistics of especially our integer or our numeric columns. Okay, our numeric columns. So if we go back to R and we run this code there, let's go back to R and we run this code there, then it should give us basic statistics of our integer columns. As for the character columns, it will just give us the length of it and then the variable type. Since we cannot have the mean, median, and quartiles for the character value, so it will just give us the length of it, and then the type of data it is. But you can see our integer values. Okay, ID number, we don't really calculate base for ID numbers because it doesn't tell us anything. These are just numbers you assign to participants in the study, so they don't tell anything. So this is malaria parasite count. So you can see the minimum value there is 0. Our first quartile is 0.00. The median value is 0.00. The mean value is 22.64. Third quartile is 0.00. The maximum value is 6,400. Yeah, 6,400. Okay, 6,400. All right. So this is how you can usually have an overview of your data before you can proceed to do data processing and other analysis. So when you have imported your data into R and you have looked at it using these functions, let's go back to them. Let's review them again. We go to Notepad++, and then we have imported our data by giving some arguments to it, and then we have shown how we can name rows in our data using the rows.names function. We have shown how we can name our columns in our data using the columns.names function. We have shown how we can tell R that, okay, treat this column of our data as factor using the as.factor function. We have also looked at the head function where we can take a look at the first specified number of rows of our data. We have also looked at the structure of our data using the str function. We have looked at the dimension of our data using the name function and the summary function, which we use to look at a brief description. These are the descriptive statistics of our numeric values. All right, so from here, we know that our data has been imported correctly. So the next thing we do in the data analysis pipeline is to pre-process our data. So data pre-processing is very, very important. And this is where you usually spend most of your time because you have to write some functions, to manipulate some columns, to remove some columns, to add some stuff. Okay, and this is very necessary, because if you don't do this one very well, the analysis you are going to do downstream, it's going to be wrong at the end of the day. That is, if you don't process your data well and you use it to run the analysis, you might get results, but it doesn't reflect the correct results as if you would have processed your data very well. Okay, so for this reason, you usually spend a lot of your time processing your data. So we are not going to be using this data set. It was just to show you how you can import data in R. However, we are going to use one of R's built-in data sets. Now, R has a lot of built-in data that you can use for learning. Okay, and you can easily access this data using the data function. If you just type, if you write this code in R, R will give you a list of the data. Okay, R will give you a list of its built-in data sets. Aside R's basic base data sets, almost all a lot of packages come with their data sets, which you can also access. But here we are going to use one of the R's building data sets. So let's run this code and then see the data sets that are present in the R. So you go back to the R GUI. You will clear the interface using Control L, and then you run this. Alright, so you see we have a lot of data set. Okay, we have a lot of data set printed here. Okay, so you see we have a lot of data set printed out from here downwards. Okay, so here we will use the empty cars data set. Okay, we will use the empty cars data set. Let me see, it should be down here. Okay, this one, empty cars data set. So to look at what this data set is about, let's use the question mark function to see what is there. Okay, so we can close this page, we can close this console, and then we will use the question mark empty cars function, question mark function, and the data set to see what is there. Okay, so this will also open it in your default browser, right? It will also open in your default browser. So let's go back to our default browser and see what is there. Okay, so we have information about it printed here. It says the data was extracted from the 1974 Motor Trend US magazine and comprises fuel consumption and 10 aspects of automobile design and performance for 32 automobiles. That's 1973 to 74 models. And it gives you usage. So the data format is provided here. So first column, the first column is MPG, that's miles per gallon. The second is cylinder, that's number of cylinders. The third column is displacement. You have the gross horsepower, rear axle ratio, the weight of the car. We have the quarter miles time. We have the engine type, whether V shape or straight engine. We have the transmission, whether it is automatic or manual. We have the number of forward gears. We have the carburetor number, the carburetors, number of carburetors. Okay, in the data. So it tells you the publishers of the data. So I think this is a journal you can find. Okay, these people publish this data, right? So this is the data we are going to use. Okay, so let's go out of our browser again to Notepad++. All right, so to use any of the data sets in R, like we use the data function to see all the data, we can use the data function and provide a specific data set, and then this is what we are going to use, right? Empty cars, right? So if we run this, we have imported this data into R. Okay, so if we run this one, Control C, we copy this and go to R, our GUI, and then we run it. Alright, so we have mounted this data set in R, so we can use it. Okay, so let's run the other functions we use to in the other data set to see. So we can run the head function, head empty cars, to see the first few rows of our data set. So here we have the first 6 rows. Okay, so we can use the dimension function once again, empty cars, and we get the dimension. So you have 32 rows and 11 columns. Okay, we can view the structure of the data, empty cars, right? And we also have it 32 observations, dash rows of 11 variables, 11 columns, and all are numeric variables. All the columns are numeric. Okay, so this is like a data, a matrix. One type of data. So this is uh, not a data frame, a matrix. Okay, if we had mixed data type we had in the imported data, the other data we imported, where we had integers and then character variables, then that is not matrix. It is a data frame but not matrix, because matrix has the same data type. If it is character types, it is character. If it is numeric, it is numeric, right? Okay, so now we have imported this data. You will look at some basic data preprocessing techniques. One thing you usually have to look at first is let's go back to Notepad++. So you usually want to see whether there are missing values in your data. Now missing values are very tricky. If you have missing values in your data and you want to run some analysis on them, you get errors. Okay, you get errors. So you want to see if there are missing values in your data set. And to do this, you can print the total sum of missing values in your data set using the sum is.na function. So in R, missing data are coded as NA. Okay, it's like not available. That is missing, not available, or missing. If you see this, any empty values are put NA there, so this data is missing. So if you want to see the sum of missing values in our empty cars data, we will say sum. By the way, the sum function calculates the sum of values. Okay, sum of values. Okay, so we say sum as dot NA. Okay, sum as dot NA. So we are telling R that, here we are actually converting it to NA. This sum is dot NA. Okay, then we provide our data set empty cars. So here we are telling R that, okay, in our data set, if an entry is NA, that means empty, count the sum of them. Okay, count the sum of NA values, that's empty values in our empty cars dataset. So let's copy this and run it in R and see what we have. Whether we have empty values there. Actually, let's clear the screen using Control L, and then we paste this one there and we hit enter. So you see here we have 0. So it means we don't have empty values in our data set. So since we don't have empty values in our data set, this data will not have any issues about empty values. However, say we had empty values in our data set. How do we deal with that? How do we deal with empty values in our data set? Now, one way to deal with empty values in data set is just to remove them. Okay, we will remove all columns. If there's an empty value in one of the columns in our data, remove the whole row. Okay, so we've collected our data. The data included ages of participants, the sex, educational level, etc. But some participants, the age column is empty. So what do? We can easily say, okay, drop all participants whose age value is empty, who did not report their ages. Okay, drop it. But in statistics, this is not a good thing because this can introduce bias. Okay, we are not going deep into statistics here, but this can introduce a type of bias called, I think it's attracing or something like that here in statistics. So, but if for some reason we wanted to remove it, so we could easily do that. In R, the function to do this is we just use the na.omit. Na.omit function will remove empty values in our data set. Okay, so let's try it. Say we had missing values in our empty cars data set. So we will now say let our empty cars data set, okay, we will say now let it equal to missing values dot omit our empty cars, our empty cars data. So we are saying that, okay, our empty cars data set is still our empty cars data set, but this time remove, okay, now our empty cars data set is now equal to our empty cars data set, but remove or omit the missing values. Okay, omit the missing values. So if we run this code, it should remove all missing values from our data set. Okay, it should remove all missing values from our data set. So let's run it. We just run it to make sure it is correct. So if we don't get error, it means the code is correct. But nothing is going to change in our data since we don't have missing values. Okay. So but let's just run it to make sure we wrote a correct code. Okay. So we open our RGUI and put this one here and run it. Okay. So to confirm that nothing has changed in our data set, okay, no missing value has changed, we can look at the dimension again to see whether some rows have been removed. So we just say dimension our empty class data. I'll be writing empty class. Our empty class data. Close. And then I didn't spell it well. It is empty class. Okay, so this is why I don't type directly into the R console. If I had typed it in the Notepad++, then I will read the code and see that, okay, I've spelled empty cars data wrong, so I will change it before I copy it here. Right, good. So you see, the dimensions of our data still remains the same. We still have 32 rows by 11 columns, so nothing changed. Okay, nothing changed. So, and like I said, removing empty values can bring bias in your data because you are automatically, in that case, your sampling is not random again. You are removing some people, some participants from the study. So they don't have equal chance of contributing to the study as other people who have their age present. You are removing them. And maybe these people you are removing, they have similar characteristics. And if they all have similar characteristics, it means you are doing bias towards this particular character. Okay. So that's just a basic explanation. You are not going deep down into statistics. So another way to deal with this is instead of removing all the participants with empty values in say their age column, we could have calculated the mean age of the participants and say, oh, okay, wherever participant has no age, put the mean value of the participant in the empty space. Okay, use the mean value for that participant. Okay, and to do this, oh, okay, you can also use the median. Right, we can use the mean, replace with the mean, or we can replace with the median. Okay, so to replace with the mean value, so to do this, it's easy. You can reassign the column. Okay, you can reassign the particular column you want to replace the missing values in it. So let's say in our data set, our miles per gallon column had missing values. So how do we deal with that? We would go and reassign our miles per gallon column. And how we do this is that, okay, we say our empty cars miles per gallon column. So this refers to our empty cars miles per gallon column. You just type the name of the data set followed by the dollar and then the name of the column. Okay, so we say that if our empty cars name per this column is dot na, okay, is dot na of our empty cars miles per gallon. So we can just hit tab and then this one will autocomplete. Okay, so what we are doing here is that for reassign our empty cars column, but for empty values in our empty cars column, do something. Okay, do something. And the something we want to do is that we bring the assignment operator and then we will say what? We want to use the mean for our empty values, right? So we will say mean in the mean function calculates mean values of a vector. Okay, so you say the mean of our empty cars column. Okay, so we can just select this one and then press tab and it will autocomplete. Okay, so we are saying for reassign our empty cars data, our empty cars miles per gallon column, but change the missing values with the mean of the column, the same column. Okay, with the mean of the same what column. And now we will say what when we are calculating, but when we are calculating the mean value, let's remove the empty values before we calculate the mean. So we do it, say NA dot remove, then equals to, then we say true. Okay. What this thing does is that before calculating the mean value of our miles per gallon column, it will remove all the missing values, the NA values. RM means remove NA missing values. Okay, true. Remove them. If it is false, it means don't remove them. But true means remove them before you calculate the mean. And when you calculate the mean, put the mean back in the empty values. Okay, put the mean, calculate the mean by removing the empty values. Now when you calculate the mean, put it back into the empty spaces, the NA spaces of our miles per gallon column, right? So let's run this to make sure our code is correct. But since we don't have missing values, this will not change anything in our data. Okay, so we go to our argui and paste this function there, right? And then run it. Okay, it has been executed successfully. Okay, so if we had missing values in our column MPG, it will calculate the mean of the column by removing the empty values first, then replace the missing values with the mean. Okay, that's the assignment. Put this one in this missing values, right? Good. So now we have, if you wanted to use the median instead of the mean, then you just, instead of saying this one is mean, we will say it is median, right? We will just say it is median. Okay, calculate the median, right? The median value, the middle value. Okay, calculate the middle value. Alright, so I am going to do this one. Okay. Um, okay, so let's say for some reasons we just wanted to remove some participants from our data, or say some rows from our data. We just don't need them. We want to remove them. Okay. So how we do this one is that we say in our data empty cars, right? Empty cars. We subset. We use the square brackets. Then we provide our number, our rows, comma, our columns. So if we don't put anything here, we bring comma. That means we are saying, okay, bring all our rows. Okay, bring all our rows. And if you don't put anything here, we are saying, okay, and all our columns, right? And remember, I said if you don't give the names of the rows, they are numbered from 1 to the end. Okay, from 1 to the end. So we have 32 rows in this data. So the first row is 1 and the last row is 32. So let's say for some reason we wanted to remove the first row from this data. To do this, we just say -1. Okay, if we say 1, it means we want to print the first row. But if we say -1, we want all the rows, but we don't want the first row. Okay, we don't want the first row. So this will remove the first row. So we don't want to modify our empty cars data. So let's put this one in a variable. So let's call that variable row1, row removed. Okay, we just say row removed, and then we assign this into it. So we are saying that for remove the first row from our data and store it as row removed. So let's run this in R and see what we have. Okay, we will run this. we'll go to our array and then run this. Good. So now let's print the first 2 rows of our empty cars data and then print the first 2 rows of our row remove data and see the difference. Okay. So to do this, we will say head empty cars right? First 2. Okay. You run this, right? So we also say repeat the same function, but this time not empty cars but our row removed data. Okay, so we run this one too, right? So what you see here, you see that here the first row is Mazda RX4 and the second row is Mazda RX4 WAG. When you come here, you see that you don't have the Mazda RX4, but it starts from the Mazda RX4 WAG. Okay, so we have this row being removed and then we start from the second row because we said this one remove the first row, right? We said remove the first row, so it has removed this row from the data. Okay, this is how you remove a row from data set in R. So you can also add a row in data set just as you can remove a row in data set. So to add a row to data set in R, we use a function called rbind. Okay, we use a function called rbind. Okay, this is the function we use to add a row in data in R to data in R. Okay, so you say rbind, then the data we want to add the row to. Let's say you wanted to add the row to our row remove data. So you say row comma removed. Okay, row comma removed. Right, row comma removed. Row removed. And then we will provide the entries of the row. Remember our data set has how many variables? 11 variables. So our entries here should be 11. So to do that, we can use the data frame function. Sorry. So here we will just use the rbind function, that means row bind to the row. Okay, then we will provide the entries. So first we have to provide the car name. Okay, the name of the car because that's the first column, the name of a car. So let's just say this is Mazda, Mazda. So this one it is a string, a character value, so it has to be in quotes. Okay, comma. Our second value is numeric, so let's just provide a number for it. Alright, okay. So the rest are kind of numeric. Okay, you can just provide numeric. You can provide numeric. So 1, 2, 3, 4, 5, 6. Then 7 is also numeric. Then 8 is also numeric. And then I think the 9th row or the 10th row is the gear type. Oh, okay, let's print the structure of the data and see what is there. So let's say str, comma, empty cars. Okay, so here everything is numeric, so everything is numeric. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, everything is numeric. So we actually do not need that there. So we go back here. So this one is numeric. So let's just put a value there. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, so 10, 11. Right, we close this one. Then we close this. So if we run this, these should be appended. These should be appended. Right, they should be appended to our data frame. So let's try it. Control C. Wait, but where are we appended it? Okay, row removed. The data frame we just need by removing the first row. Okay, the data frame we made by removing the first row. So you go back here and kind of run it. Good. So here, right, so you see that it has been appended. Look at it here. The values we provided have been added here. So we didn't give the row name. Okay, if you had given the row name, then this would be done. Okay, if you had given the row name, then this would be done. Let's try that. Let's try to give a row name to our data. So we will just say that here, okay, we will say we will call this Mazda equals to this. Okay, we will call this Mazda and it is equals to this. Right, this should append it here. Okay, but first of all, let's remove the row we just added so that we can add it back. Okay, we will remove it and then we add it back. And to remove it, we can use this one and remove the what? It is the 30. Let's go back to our argue and see. Okay, we are already in our argue. Sorry. Oh, I didn't open the notepad plus. So it is the 32nd row. Okay, it is the 32nd row. Since we removed the first row, it is not the 32nd row. So we can remove it. Alright, let's go back to the notepad plus. In the notepad plus, we say that what? Now a row removed. Remove the minus 32. Remove the 32nd row. So we will have it like this. Control C. Now go back to our argue and run this. Okay, and run this. So that is done. Okay, that is done. So if we print, so now we can run this. But now we have provided the name of the car as the row name, right? Let's go back to notepad plus. So we will append the row again, but now we are assigning a row name. Mazda is equals to this. So this will take this as a row name, append its values to this data. So let's run it and see. We go back to our GUI and run this. Right, so now you see at the end, we have, instead of 32, we have Mazda, right? And we have the values here. That is great. So we have added a row to our data. That's okay. So just like we have added a row to our data, we can also add a column to our data. So to do this, you just, let's go back to Notepad++, and I'll demonstrate it. So to add a column to our data, we just provide the data set and the column name. So we want to add it to our, no, not our empty class data. Let's just, we are modifying this, our row remove data. So we want to add a column to our row remove data. Row removed. Okay, I'll just hit tab and then it will go. So the new column we want to add, so $sign. What column should we add? So let's do some calculations. We will calculate a value from two of the columns and use it to form a new column. Okay. So let's do the horsepower to weight ratio. We want to see the power to the weight of the car. Okay, the power to the weight of the car. So we will say this one, power to weight. Okay, so you assign it to, it is the horsepower, so it is from row removed. And then which column? Horsepower is HP. Now divided by, so this is the division sign in R. Okay, the forward slash is division sign in R. So you also say row removed again. Right, so which column? Weight. I think the weight is WT. Yes. So now we are saying that we want to create this column, power to weight, and add it to our data set. And then its values are for every row. Calculate the horsepower to the weight ratio and put that value inside our power to weight. Okay, so if we do this, it will calculate for each row and then append at the end, append that row, that column to the data set, row removed. Right, so let's copy this one and then go back to our GUI and run it and see what we have there. Let's paste it here and run it. Right, so we have run it. To see that this has been effected, let's print the structure of our row data again and see. I think we did it earlier. Okay, so it is, okay, we printed the structure of our empty class, but now let's print the structure of our row removed data. Okay, right, so you see now instead of 11 variables we have 12 variables and a new variables has been added, power to weight. Okay, with the ratio, with values, and these values are the ratios of the horsepower, which is HP, to the weight, WT, of the car. Okay, so to verify this, let's kind of try for the first row. You see that the horsepower is 110 and the weight is 2.62. So 110 divided by 2.62. Yeah, 2.62 is what? Right. it is 41.98473. So here you have 42. It has been rounded. Okay, it has been rounded up, so that when you do one decimal place, so when you round this, this is 8, so when you add it here, it becomes 10, so you have 42, right? Good. So this is how you also add a column to your data set in R. So let's go back to Notepad++ and see what we did. So we have looked at how to create we have looked at how to remove rows. We have looked at how to create new rows. We have looked at how to create new columns. Okay. I also demonstrated how to remove columns, right? So to avoid doubts, let's just look at it, how to remove columns. So let's say for some reasons, our column you have added, we don't want it again, we want to remove it, right? We want to remove it. So now we will say that what? I think let's just copy this code, it will modify it. So we will say in our row removed data, so assign our row removed data to root again. But this time around, give us all the columns, the rows, but kind of remove the 12th row, because the row we just added is the 12th row, right? So I mean the columns we just added is the 12th column. So we say minus 12, remove the last column, the 12th column. If you wanted the first column, then we just say minus 1. Second column minus 2. So 12 column minus 12, right? So if we copy this, let's run it and see what happens. We will go back to the argui, and then paste it here and run it. So it has been executed successfully. So let's do our structure of our data and see if we still have this 12 row there. If we have it there, it means our code didn't do exactly what we wanted to do, right? So let us, okay, structure of our row removed. Good. Great. So you see that we don't have our power to weight ratio there again. Now the last thing is the cabrito. Is a cabrito, yes. So it has been removed, right? Yeah, so we have looked at how to remove rows, how to add rows, how to remove columns, how to add columns. Okay, and we have also looked at how to do calculations from one column and use it for another column. So basically that's what we did. Like we took the ratios of the horsepower to the weight, and then we used that one for our power to weight column. Okay. So one thing you want to also do in your data set is subsetting or filtering. You want to filter your data based on certain criteria. Okay. Maybe let's say for our miles per gallon, our MPG column. Let's go back to the data. Okay, we are here. So let's say for our MPG columns, we want only rows that are greater than, let me say, okay, we have 21 here, 22 here, we have 80 here. Okay, that are greater than 20. You want only rows that are greater than 20. So let's try and do this. We go back to Notepad++. And try and filter our data such that we have only rows that are greater than 20. Okay, so let's assign it into a new variable. We will call it filtered data. So I don't want us to modify our empty cars data. Okay, that is why I create a variable and store the modified data in that, so that our empty cars data still remains the same. Because if we do our empty cars data, we assign this to it, then our empty cars data we have mounted in R will be modified. But when we assign a new variable and store the output in that one, then we have our modified data stored there, but our empty cars data still remains the same. Okay, so we say filtered data, then we assign it into this. Then we say it is equals our empty cars. So how we do this is that we will say that let filtered data be equal to our empty cars data. Okay, our empty cars data. But this time, our empty cars data miles per gallon column should be greater than 20. Right, something like this. It should be greater than 20, right? Yeah. So this column for only filter for only rows where this column is greater than 20. So for any row where the column is less than 20 should be removed. Okay. And how many columns do we want? We want all our columns, so we don't provide anything here. So remove rows that are less than 20, but print all our columns. Print all the columns for all rows that are greater than 20. That is how this one is. So store all the rows where the column value is greater than 20 in this filtered data. So let's run this. We go back to our argui. Okay, here, and then we paste this there and we run. Alright, it has been executed. So now let's take a look at uh, our filtered data. Let's look at the dimension. Okay, we know that the dimension of our original data empty cars is 32 by uh, 32 by 11. Yes, 32 by 11. But now since we have values in the MPG variable, in the MPG column that are less than 20, and we say we are filtering those values out, so now we should have lesser rows than the original. So if we do it and we still have the same rows, it means our code didn't do the thing we wanted to do. So let's look at the dimensions of our filtered data. Okay, of our filtered data. Close it and run it. Right, we have 14 of 11 instead of 32 of 11. Yeah? 14 of 11 instead of 32 of 11. So how many has been removed? How many rows have been removed? So 32 minus 14. Right. So 18. 18 rows had MPG values less than 20. I mean, less than or equal to 20 because we said greater than 20. So even if it is 20, we remove it. So 18 rows had values that are less than or equal to 20, and they have been removed for our filtered data. But our empty cars data should still be the same if we look at the dimension of our empty cars data. So it should still be the same. Yes, 32 by 11. Because we didn't modify it. We stored the value in here. If you wanted to modify it, then we will say our empty cars data should be modified. This should be put in our empty cars data. But we didn't say that. We said put it in a different data variable called filtered data. Good. So we have looked at how to filter rows. We can also look at how to filter columns. Okay, we want to subset some specific columns from our data. We don't want all the columns. We just want some of them. So let's go to Notepad++ and see how we can select some columns and not all the columns. Okay, so let's call it selected columns. Okay, selected columns, and then we assign it to. So we say we want to select some of our empty cars columns. Okay, our empty cars columns, right? So we say select some of their columns. So we need all the rows, so we just don't put anything there. Bring all the rows, but we want some columns. So see by the columns you want, right? And the columns you want should be what? Let's say you want the miles per gallon as again mpg. So this is like I said, it is string, so it should be in quotes, right? You want mpg, you want cylinder, let's say so, right? It should be so. So you have to spell it correctly, right? You want the so. I mean, let's just select these two, right? We can just select these two. So if we do this, we say that we are selecting for these two rows, these two columns, all the rows of these two columns. Okay, so let's run it and see what we have. Control C, we go to Argui. But let's clear the screen. It is messy. Control L and it is gone. Then we run this. Alright, so let's look at the dimension of our selected columns. Selected columns. Alright, it is 32. 32 is all the rows and two columns because we selected two columns, these ones. Okay, we selected two columns, these ones. We can look at it, but we don't want to print all 32 rows. So let's use the head function. Head, I usually like to do it like this. So instead of dimension now, we will say head. Okay, so we want to see, this will give us the first 6 rows, right? So we have our rows here, we have our columns here, 2 columns, mpg, cylinder, right? So we have looked at how to select filter columns, we have looked at how to subset rows, we have even looked at how to filter columns based on certain criteria. Okay, we say if the value is greater than this, select them. If it is less than that, leave them out. Okay, so there are a lot of things you can do in the data pre-processing stage. I have already told you that this is where you actually spend most of your time. This is what you spend most of your time doing, and you have to do that to make sure the data you are sending to the downstream processes, that's for plotting your graphs and then for running your statistical test, it's in the ideal state. You are not using wrong data. Alright, so but this is what we will look at for now. You can always find more, and maybe I'll create subsequent videos or something to go into detail on data pre-processing techniques. So let's look at how to visualize data in R. So now we have our empty cast data mounted in R. We have looked at the data, the nature of the data. We have done some filtering, hypothetically, because we didn't actually do them on the data set because we do not have empty values in those things. But we have looked at a scenario if you have these issues, how you can deal with them. So hypothetically, we have done that. Okay, so let's look at how we can draw plots in graphs in R. Yeah, plots. Let's go back to Notepad++. The first plot we would draw, we should draw what? Let's draw a scatter plot. We will draw a scatter plot for our horsepower and our miles per gallon. We want to see the relationship between the horsepower and the miles per gallon, right? So how we do this? We use the plot function. In R, we use the plot function to do graphs, to do a scatter plot. So we just say plot in the bracket. Then you bring the variable you want to plot. We say we want to plot empty cars. Okay, we want to plot this. Okay, but this is not the first one we want to plot. We don't want to plot this one first. We will bring the horsepower first, so that it will be on the it will be on the, what do you call it? The x-axis, so that the miles per gallon will also be on the y-axis. Okay, so we separate them by comma, right? So comma. We want to give a title to our plot. So now you can write this thing on a straight line. Nothing is wrong with that. But to make the code nice, you usually just break it. It doesn't matter. It doesn't have any issue. But to make it nice, so we want to provide a title to it. So the function we use for that is the main function. So you say equals to, then you give it a name. Okay, you give your plot a title, right? So what are you plotting? We are plotting horsepower against, or let's just say, verse miles per gallon, mpg. Yes, this will be the title of the graph, comma. So we provide the x label. So the label on the x-axis, what should it be? So it is the horsepower. So the horsepower will be on the x-axis because that is what we brought first. Okay, so it will be the horsepower, right? And then the y label equals to, so the mpg will be on the y-axis. So we say miles per gallon, right? Miles per gallon. And what do we want to provide again? Okay, let's give color. Let's add color to the points. Okay, you can add color to the point. So we bring comma. So any attribute you want to add, we just put comma and then we add it. Okay, so here, if we had run this code, then you'll get an error because we didn't bring the comma. Okay, so we bring the comma. Then we want to add color, so we use the col function, which is for color. Then we provide the color name. Okay, here you can provide color name. So let's say blue. We want blue color, right? So let's provide the style of the point. So you want a circular point, a small circle. Okay, a small circle point. So to do that, we use the PCH. The PCH attribute is for the style of the dot you use to plot it. So let's say the point is 2 on the x-axis, 4 on the y-axis. So you trace it to that point and then you put a dot there. So what do we want to put at that place? Okay, so let's say it is 16. So this one is values. I think it ranges from 1 to 20 something or something. Yeah. But 16 is a circle, a small circle. Okay, 16 is a small circle. 16 is a small circle. So I think we can plot this. So you close it. Because remember, when you use the plot function, you should have a closing parenthesis. So we want to plot horsepower. You see, I didn't also bring the dollar sign here. So we want to plot this column horsepower and this column miles per gallon. Okay, so we gave it a title, we gave it an X label, the label on the X axis. So let's make this one uppercase horsepower. Okay, and then we gave it a Y label, miles per gallon. We gave it a color, blue color. We gave the style of the point. Okay, we gave the style of the point. So let's copy this and go to our Argui and plot it. Right? Let's plot it. Argui and just paste it there. Right, and run it. Voila. So you see, we have our plot here. Right? We have our plot here. We have the title, the header of our plot, horsepower versus MPG. And then we have on our Y label miles per gallon, and we have on our X label horsepower. Right, and our points are we provided 16. So small circles. And we provided a color, blue color. So we have blue color. Right. Great. So this is how we draw the scatter plot in R. So what plot again? We look at histogram, right? Yeah, we can draw histogram for, okay, when you do scatter plot, you need two variables. How two variables correlate? Histogram, you are categorizing one variable. Yeah, we can draw histogram. We can draw histogram. Yeah, so here you can see there's a roughly negative correlation between the horsepower and the miles per gallon, right? As this one is decreasing, this one is increasing. As this one is decreasing, this one is increasing, right? So there's an inverse correlation here. So graphically, you can see when you draw your graph, you process your data well, and then you draw the graph. You can just look at it and see the pattern. Okay, you can see whether when this one is increasing, this one is decreasing, or when this one is increasing, this one is also increasing, right? All right, so let's go back to our notepad plus plus and look at histogram. So let's draw histogram for, again, our miles per gallon. Let's draw histogram for our miles per gallon. So to draw histogram, the function is hist for histogram, right? The function is hist. So close. So usually you have to always do this, right? Always do this. So also kinds of accept the same things. So we want to plot for our this variable miles per gallon here. So we put it here, comma, right? So you have the labels again. So you have our main, we have our main, and we will have our X label, we have our color, we'll give it a color, and yeah, so let's do it. So the title, what should the title be? Let's say it is distribution. Yeah, it's a distribution, right, of MPG values. Yeah, the distribution of the MPG values, right? Okay, so our X label, right? So we provide it with an X label because the Y label is just going to be the frequencies, right? The Y label is just going to be the frequencies. So our X label is going to be the variable MPG, right? But let's write it in full. Mouse right. Our Y label is going to be frequency. So let's just do it. Let's say it is frequency. Frequency. Yeah. Okay, so we can provide a color. So this time around, we'll give it a light blue color, or this was blue color, so this we can give it a light blue color. Light blue. Yeah. So let's run it. Let's run it. So we have our variable we want to plot. We have the main, that's the title. We have the X label, we have the Y label, we have the color. Good. So we go to our RGUI. And we will run it. So let's paste it here. Have to activate it. So there's an error somewhere. Oh, okay. So you see what I was talking about. I've omitted the comments, the comma that separates the values. Let's go back to Notepad++ and you see what I'm talking about. Here. Alright, you see, I didn't bring the comma here. So there should be a comma here. There should be a comma here. And there should be a comma here. Right. See, I didn't bring it and then I had the error. Okay, so copy it. We'll run it here. Alright, so we have this cool graph. Okay, so we have our miles per gallon, we have our frequencies, and it has been categorized, right? From 10 to 15. How many cars have miles per gallon in the range of 10 to 15? So it's about 6. Okay. How many in the range of, this is like from 11 to 15 actually. So this one is 16 to 20. Okay. This is 21 to 25. Yeah. 26 to 30. 31 to 35. Okay. So within this range, you have around 12 cars there. Right. Within this range, you have about 9 or so. Yeah. You have about 9. Alright. So that is histogram. We use the hist function, right? We use the hist function, then we give the data we want to plot, then we provide the main, then we provide X label, Y label, then the color. All these are optional. You can just run it with this and it will give you results. These ones are just to add more context. Okay, to add more context. So the next thing we will look at is let's do a box plot. Okay, let's do a box plot for okay, MPG again and cylinder. Okay, you want to see for each cylinder type. Okay, for each number of cylinders. For each cylinder category, what is the maximum MPG value, the minimum MPG value, the median, and then the mean. You see the 5-number description. We'll do a box plot for that. So let's go back to Notepad++. Notepad++, and then so to do a box plot, we use the box plot function. And then we will give our variables, and then just like this other graphs plots, you also have the main, you have the X label, you have the Y label. You can also provide the colors for your, the colors, right? So, but first of all, let's look at the cylinder, the unique cylinders. Okay, to do this, let's go to the algorithm. We can do unique. Okay, this will print the unique values for the cylinder, empty cars, right? Which column? So, right, we run this. So a car either has 6 cylinders or 4 or 8. Okay, 6 or 4 or 8. So we have 3 categories. You draw box plot that will show the maximum, minimum, median, mean for the 6 maximum, minimum, median, mean values for the plot those values for the miles per gallon for 6-cylinder cars, and then for 4-cylinder cars, and then for 8-cylinder cars, right? So let's go back to our Notepad++ and do this. So like I said, we use the box plot function. Okay, Notepad++ to draw box plot, we say box plot. Okay, bracket, then yeah, then we can provide our variables. We want to draw empty cars, miles per gallon. Then we use the tilde function, the tilde. Right now, we are not plotting this against this. We are categorizing MPG based on cylinder, so we use the tilde function. The tilde symbol. This symbol is called tilde. You can find it on your keyboard, depending on the keyboard you are using. On my keyboard, it is just below the escape key. Okay, on the upper left corner, just below the escape key. So you press shift and the key below the escape key, and you get the tilde function. Okay, empty cars, MPG tilde, empty cars, so cylinder, yeah, so right. So we say our data. Oh no, since we are going to provide the data, we don't need this, because we will provide the data that we are extracting these values from, right? So we are saying extract these values from this data. Our data is equals to what? Empty cars, right? Like this. So comma, yeah. So we are saying that extract these columns from where? Our empty cars data set. Okay. Alright, so let's just provide the values. So you say our main, and the main, what should we name the main? What should we name the graph? MPG by cylinder. Does that sound well? Yeah, I think that sounds good. So the main should be equals to MPG by cylinder type. Okay, now if you are doing publication graphs, you usually have to spell these things in full. Okay, or you provide the abbreviations for them at the end of your publication. So I'm just showing you how you can do it. Okay, right. So you will have our X label. So now in the X label, what do you think we have in the X label? Think about it. So the X label will be the cylinders because we are categorizing the cylinders, and then we are plotting the box plot for each cylinder category. So on the x-axis will be the cylinder, right? And then on the y-axis will be the descriptors for the miles per gallon, right? So this side will be cylinder, comma. So our y label will be equals to what? Miles per gallon. Good. So we have this, and we can also okay. So we also give a color, right? We also give a color to each box plot, right? We have 3 box plots because the cylinders, we have 3 cylinder categories, so we will have 3 box plots. So we can provide separate color for each box. Okay, so if you are providing a value of colors, then we use the C-bind function. We remember when we are providing a value, a set of values, we combine them, right? Like combine these values. Okay, so we use say red. What colors should we use? Yeah, let's just use red, blue, green. Yeah, red color, blue color, and then green color. Right. So we close this. So the first box plot will have red color. The second one will have blue color. The third one will have green color. Right. So let's draw it. Control C. Copy it. Go to our Argui and voila. Let's clear it. Or let's just paste it. So we paste it and then we run. Right, beautiful. So we have our box plots here, right? So for 4 color cylinders, for 6 color cylinder, for 8, for 8 cylinder car, for 6 cylinder car, for 4 cylinder car. So you see that for the 4 cylinder car values are actually higher than the 6 cylinder and the 8 cylinder. You can see that. So the number of cylinders has some kind of correlation with the miles per gallon. Okay, so you have the median value here, we have the minimum value here, we have the maximum value here, we have the upper quartile here, we have the lower quartile here, right? So this is how we draw box plots in R. And there are usually a lot of things you can do, but basically this is how we draw it. Okay, this is how we draw it. So our next graph we will draw is let's draw a bar chart. Yeah, let's draw a bar chart. Bar chart for which variable? Let's draw a bar chart for we've used MPG for too long. So let's draw a bar chart for horsepower, right? We'll draw a bar chart for horsepower. So you see that the horsepower values are continuous, right? Let's look at them. We'll go back to the argument. Let's look at them. The horsepower values. Let's just print the head. Or we can just print the empty cars. HP, horsepower. Alright, you see them. They are continuous, right? Continuous variable. So to draw a bar chart for this, we will need to categorize these values. Okay, we need to categorize these values so that we have the bars, separate bars for them. Okay, so to do this, let's first build the bins. Okay, the categories, right? So let's go to Notepad++ and say that what in Notepad++, we will say we want to create bins. Bins are the columns. Okay, we want to create the bin for our HP horsepower variable. And to do this, there is a function called cat. Cat in R is used to make categories of a variable. Okay, so our HP bins, so HP columns, so we will store it in this. So the function cat is used to make categories of a variable. So the values it accepts include the variable itself and then the breaks and the labels. Okay, so the variables we want to do is the empty cars HP. Good. Empty cars HP. So the breaks. The breaks are the categories. Okay, so we say C bind. Right? We say C binds. How many bins should we cut it into? Let's say we want about 5 bins. You want 5 bins. Okay, so you cut it into 50, 50, 50. Yeah, 50, 50. So C bind, we will say from 0 go to 50, go to 100, go to 150, go to 200, go to 250, right? Go to 300, and then go to 350. I think the maximum value is not above 350. Yes, it is not above 350, so we can stop at 350. So 300, 350. So the maximum HP value, horsepower value, is not above 350. So this should be okay. Okay. So we can provide labels for these categories. So we say labels. The labels should be equals to what? I mean, the labels should be equals to C bind again. So the first category, let's say it is very low horsepower. Right? So we have a low horsepower. Right? So we have a medium horsepower car. This is medium. Right? We have a high horsepower car. Right? And then we have 1, 2, 3, 4. Then the fifth one, it should be like very high horsepower car. Cool. So we close it. Okay, so we close it. So we have closed our labels. So we are creating 5 categories: very low, medium, high, very high. Right? So let's break this down. HP means we copy it and go to the argue and run it. Right? Let's run it. If you look at our values, okay, we have 335. Yeah, it's 350, so 335 is still below 350. Yeah, so it should be able to contain it. Error here. Number of intervals and length of labels differ. Okay, so I have 1, 2, 3, 4, 5, 6, 7. I have 7 labels. How? Okay, so I will, let's cut the breaks. Okay, let's just cut the breaks. What are we doing from 0 to 100 to 150, 200, 350? Yeah. So let's go back to Notepad++. And then, so this one, instead of this, let's just make four categories, right? 4 categories. So we will do from 0 to 100, right? 0 to 100, and then we will do 100 to 150, right? Then we will do 200, we will do 350. So from 200 we jump to 350, right? If we do it like this, so we have 1, 2, 3, 4. We have 4 categories. So let's run this one. Control C. Go to Argui. And run it. Alright. So we have our beans. Let's see how it looks. HP beans. Alright, so we have medium, medium, low, medium, high, medium. Yeah. So it has been categorized now. Yes. So we can make a table, a frequency table of these beans. Okay. We can make a frequency tables of these beans so that we use the table to plot our bar chart. Okay, bar plot, we usually have a frequency table. So we can make a frequency table of these categorized values then. Okay, so to do it, let's go back to our notepad++ and create a frequency table for this. So we call it freq HP or HP freq. Right, we assign it to what? To create a table of categories, I'll use the table function. Okay, and then you give the variable. The variable is the beans. Right, so this should create the table for us. So we will run this. You go to Argui and run the code to create our frequency table. Alright, so let's look at our frequency table. HP freq. Alright, so you see it. So low, we have 9 items. Medium, we have 10 items. High, we have 6 items. Very high, we have 7 items. So now we can draw a frequency distribution. We can draw a bar plot from this frequency distribution table. Okay, we can now draw a bar plot from the frequency distribution tables. So let's go back to Notepad++ and see how we draw bar plots. So the bar plot, like we mentioned, also uses the bar plot function. Okay, so you take the bar plot, you take the frequency table. Like I said, bar plots use frequency tables to draw it instead of using a column like we did for the other plots. So here we created a frequency table, and then you will use that one to draw the bar plot. Okay. Alright, so let's draw our bar plot here. So we say bar plot like this, just like we did for the others. And then this is our table. HP frequency is our frequency table. Right. So we also provide the labels like we did for the other one. So you provide a main. Okay. So the main is what? It is the count of cars. Car count by what? Horsepower. Yeah. Is the car count the number of cars that are in a particular category of horsepower. So horsepower category. Right. Right. This is how you do that. So now the x-axis, that's the x label, would be equals to what? Horsepower, right? Horsepower category. The x label will contain the horsepower category. So you say this is the horse power, right? Horsepower. Let's just add a category, right? And the Y label will be the number of cars, the frequency. And this frequency is the number of cars actually. Yeah. So we will give names to your columns. Okay. We will give names to the columns. Right. Let's give names to the columns. To do this, we will say the function to do this is called names dot args, names dot arguments. So what names do we want our columns to hold? Okay, our bins to hold. So we want them to still hold these names, right? Low, medium, we just like the way we've categorized it. Okay, so this should be equals to this. So we are labeling our categories low, medium, high, very high on the bins. Okay, so we can plot this. Let's plot it and see. Copy it and go to the argui and plot it. Alright, so you see, you have the number of cars for horsepower category. Low, medium, high, very high. Based on the criteria we categorize it. Okay. But one thing we can also do is that we can add a legend to this graph. Okay. We can add a legend to this graph and it is quite simple. You just say legend.text is equals to true and the legend will be added. Okay. So let's go back to Notepad++ and add legend to our bar plot code. So here to add legend, we say legend.text equals to true. Add legend text. Okay. So we will copy it and go back to our GUI. Then we will run it, paste it, and then run. Right. We run this. Alright, so you see you have a legend here. Okay, we have a legend here. We could have provided a color for this. So that one we can do it. So let's add it. We can add colors. Let's go back to our Notepad++. So we have 5 bins. So it means we should provide 5 colors, right? To do this, we also use the color attributes and provide a list of colors. Okay, so we'll just say color. Let me copy from somewhere. I have this here. Okay, how many? 1, 2, 3, 4, 5. So we have 5 colors. So for each bar, use one of these colors, right? So let's run it. Control C. Let's put this one there. Right. Good. So now we have our bars filled with colors. Right. Yes, so now this is beautiful. Okay. So this is beautiful. So now that we have looked at how to do some basic plots, let's look at how to do basic descriptive statistics in R. Okay, so we will open back to our Notepad++, and then what are the descriptive statistics? Okay, they are the mean, the median, the standard deviation, and the mode. Okay, now we will not do mode. Mode we will do in a separate video because R doesn't have a built-in function for mode. So you have to use, you have to create your own functions to calculate the mode for whatever data you are working on. Okay. So but for the mean, let's just calculate the mean, median, standard deviation for the MPG column. So you can always use any column you want. So you have mean, median, standard deviation, right? We are going to calculate this. So I said earlier that the mean, to calculate mean in R, you just say mean. So followed by the function. So mtcast mpg, right? So this will calculate the mean for this column. Okay, so you can just copy it and bring it here. But instead of mean, we say median, right? So we can also paste it here. But instead of mean, we say SD, standard deviation, right? SD, like this. So these functions should calculate the mean, median, and standard deviation for the MPG column. So let's go back to our argue and see how we do that. So we will copy each of these codes and paste it there. So first the median, we just copy it from the Notepad++ and and paste it in the argue and run it. Right, so let's run everything and then we can call them back. So let's copy these two and run them too. So over here, we just run them. So if we say mean, guess what? Right, the mean is 22.09062. Right, the median is 19.2. You see, almost close. So the SD is 6.026948. That's the standard deviation. So this is how you calculate the mean, median, and standard deviation in R. Okay. So we can also calculate the correlation between two variables. Let's just do it directly here. We use the core function, the COR function. So then we give our empty cast column we want to calculate is the horsepower, and then which one, and our miles per gallon, right? Empty cast miles per gallon, right? So this one should calculate the correlation between these two. So you see that when we drew the graph, it showed that when one is increasing, one is decreasing, and when the other is decreasing, the other is increasing. So let's run it and see. We should have a negative or an inverse correlation, right? Yeah. So negative 0.776 1684. Very high negative, very high inverse correlation between horsepower and miles per gallon. So now that we have looked at correlation, let's look at regression. We'll look at the regression between, we'll calculate the linear regression between the miles per gallon again and then the horsepower, right? So correlation tells you, well, there's some kind of, correlation between the two. When one is increasing, one is decreasing. But it doesn't tell you which one influences which. So here we want to look at how the horsepower influences the miles per gallon, right? Miles per gallon is our dependent variable, and you want to look at how it changes with respect to the horsepower. Okay, so we can use a linear model to look at this. We are using a linear model because our dependent variable is a continuous variable. Okay, miles per gallon is continuous. If it were categorical, like in two categories, then we will use a logistic regression, okay, for categorical. But since it is continuous, we will use the linear model. So to do a linear model in R, let's go back to, we'll go back to Notepad++ to see the code, how we do it. So if you want to do a linear model in R, the function is lm for linear model, right? The function is lm for linear model. And then you bring your dependent variable, which is what? Miles per gallon. And then your independent variable. And the independent variable we are using here is the horsepower. Okay. So you bring your tilde again, then horsepower, right? Then your data. Our data is equals to what? Empty cars, right? So this is how you do it. So how horsepower influences miles per gallon. But let's store this one in the variable. We don't just want to calculate it straight away. We want to store it in something so that we can call it back by referring to data. So let's just say it is called model. And then we assign it to this one. So let's run this and see. Alright, so when you run this and then you can look at the results using the summary function. So you can say summary and then model. And this will give you the results of the model. Okay. So let's copy this. We will copy this and go to the argui and run it. Alright, so then you look at the summary. I'll just copy that code and run that one again. Control C and look at it. So alright, here we have our results. So you see the results. The most important thing to look at here is the p-value. Okay, and look at it. It is 1.788 times 10 power negative 7, which is very significant. Okay, far below the 0.05 cutoff. Okay, so this means that the horsepower influences the miles per gallon significantly, right? It significantly influences the miles per gallon. So the miles per gallon for a car is influenced by its horsepower in simple terms. Okay. So all right, this is how we do basic statistical analysis in R. There are a lot, so I cannot cover everything in this video. I'll do subsequent videos and try to explain more on these concepts. But this video, if you're able to watch from the beginning to the end, you should also be able to take a data set and then comfortable run your analysis, whether for publication or for practice. Okay, so and I encourage you to always practice. Okay, for programming stuff, for coding specifically, to be good, you have to practice. All of these things, to be good, you have to practice. Just practice, 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 practice. Okay. All right. So this brings us to the end of the tutorial. And please, if you have not subscribed yet, kindly subscribe for me and like the video, and also bring your suggestions in the comments so that when I'm creating subsequent videos, I'll try to, create them taking into consideration your recommendations. Thank you for watching.